Hello everyone, I am Muskan Nagar and today we are going to discuss the solution of second internal of data science. Let's begin. First question, the Bayes theorem P of A given B. The formula of Bayes theorem is P of A given B equals to P of B given A into P of A whole upon P of B. Second question, the 68, 95, 99.7 rule describe the probability mass of the Gaussian distribution. Third, the metric that measure uncertainty gained when replacing distribution A with B is called Kullback-Leibler divergence. Fourth question, ridge regression uses an L2 penalty while Lasso uses L1 penalty. Fifth question, a model that performs well on training data but fails on unseen data suffers from overfitting. Sixth question, the logistic regression coefficients are estimated using the maximum likelihood function. Seventh question, the hyperplane in SVM that maximizes distance between classes is called maximal margin hyperplane. Eighth question, the clustering K-mean minimizes the within cluster sum of square of distances. Ninth question, in PCA, the first principal component captures the maximum possible data variance. 10th question, CNNs are particularly effective for image data, while RNNs are suitable for sequential data. 11th question, a tensor flow, the structure representing operations and dependencies is called a computational graph. 12th question, Hadoop's fault-tolerant distributed storage system is called HDFS. Its full form is Hadoop Distributed File System. 13th question, a SQL query combining rows from multiple tables based on related columns uses join clause. 14th question, the Python collection that ensures only unique elements is called set. Set only has unique elements. 15th question, bootstrapping is a resampling method that samples with replacement. The next section of this internal is match the pair. We have to match column A with column B. Here are the answers. The Manhattan distance is here k equals to 1 and the sum of absolute differences is calculated in Manhattan distance. In Euclidean distance, k is equals to 2 and it gives straight line distance. Pearson coefficient is curve x comma y upon sigma x into sigma y. Spearman coefficient is correlation based on ranks. L1 regularization shrinks some coefficients to 0. L2 regularization, it shrinks all coefficient proportionally. Bagging, a bootstrapped aggregation of trees. Boosting is sequentially focuses on misclassified samples. Ridge regression uses penalty. Lasso regression uses penalty, lambda, and sum. Next, 16th question. Compute probability a fair die rolled twice. Probability that sum equal to 7. Here P will be 6 upon 36, which is equals to 1 upon 6. As 2 dice are rolled, so we have to take 36 as total probability. 17th question, for a binomial distribution n equal to 10, p equal to 0.5, expected value will be n into p and 10 into 0.5, which is 5. 18th question, if r square equals to 0 0.8 and TSS equal to 100, compute RSS. Here RSS will be equal to TSS into 1 minus r square into is equals to 100 into 0 0.2, which will be 0.20. 19th question, in linear regression, gradient descent update rule for weight W. Here the formula will be W minus alpha into X delta J upon delta W. 20th question, for a normal 0, 1 distribution, what percent of data lies between -2 and +2? It will be 95.4%. Folk-fold cross-validation with 5k equal to 5. Each iteration uses what percent of data for training? It uses 80% of data for training. 22nd question. Compute precision if TP equal to 40, FP equal to 10. Precision equal to precision's formula is this: TP upon TP plus FP with putting the values as 40 and 1 for TP and FP, we get 0.8. 23rd question, if recall equals to 0.8 and precision is 0.4, so we have to calculate F1 score. So in the formula for F1 is 2 into recall into precision upon recall plus precision. It will be 0.533. 24th question, a model gives TP equal to 70, TN equal to 80, FP equal to 20, FN equal to 30. We have to find accuracy. So the formula is TP upon TN, the whole upon TP plus TN plus FP plus FN. By putting all the values, we'll get the answer as 0.75. 25th question, for a Poisson lambda equal to 3 distribution, expected value of lambda will be 3. 26th question, write Python code to compute mean of list A, which is 2, 4, 6, 8. Using NumPy, we can use NP equal to mean of A. 27 question, convert list 1, 2, 3 to NumPy array. We can use np dot array and put the whole list into it. 28th question, create a data frame from dictionary A 1, 2, B 3, 4 using pandas. pd dot data frame A 1, 2, B 3, 4. This can be the code to execute this. 29 question, replace all missing values in data frame df with column mean. df.fill n a df.mean method comma in place equals to true. 30th question, display first 5 rows of data frame df. df.head. 31st question, plot histogram of column height using matplot. We can use plt.hist df height. 32, apply one hot encoding to categorical column color. pd equal to get dummies df colors. 33, compute correlation between two pandas, column X and column Y. df X dot cor df Y. 34th question, find unique element in list using Python set. Set A. 35th question, add a new key value pair pi 3.14 to dict d. d of pi equal to 3.1514. 36th question, create a dq and append element 1 to 3. From collection, import dq. dq equal to dq 1 to 3. 37 question. Pop smallest element from heap. Heap q dot heap pop heap. Create numpy array of zero shape 3 comma 3. We can use np dot zeros 3 comma 3. Convert column date to date time type in pandas. pd dot to date time df date. Filter data frame row where column score is greater than 50. df of df scores is greater than 50.